In this lab, we will perform the synthesis and titration of potassium tris oxalato aluminate trihydrate. In the first part of the synthesis, you will weigh out 0.5 grams of aluminum. Your source of aluminum is ordinary aluminum foil, which is torn into small pieces. Once weighed, the aluminum is transferred to a 250 milliliter beaker. Next, 15 milliliters of 4 molar potassium hydroxide and 30 mils of water are added. The solution is stirred with a glass stirring rod to be sure the aluminum is submerged. Initially, the reaction is slow, but speeds up as it proceeds. Aluminum is a reactive metal, but it develops an oxide coating that prevents reaction. The hydroxide ion reacts with the oxide coating, and aluminum then reacts with water by displacing hydrogen. Here you see the reaction nearing completion. It will take approximately 15 to 20 minutes for the reaction to get to this point. Next, the solution is transferred to a hot plate and heated to boiling. 8 grams of oxalic acid dihydrate are then added. The solution slowly changes to a clear, pale yellow color. The solution is then placed in an ice bath and cooled to a minimum of 5 degrees Celsius. 20 milliliters of ethanol are then added and the solution is allowed to crystallize for 15 to 20 minutes. The product is then recovered by suction filtration and washed with acetone. The acetone evaporates readily, helping to dry the product. The suction is maintained until the sample is somewhat dry. Last, the product is weighed. The final product is a white crystalline solid. As you can see, 6.109 grams of product are recovered. In the second week of the experiment, you will determine the mass percent of oxalate in the sample by titration with potassium permanganate. You will first weigh out 3 samples of product ranging in mass from 0.10 to 0.350 grams of sample. In performing any titration, it is always a good idea to employ a different mass or volume with each trial. As you can see, the mass of sample employed here is 0.190 grams. Next, the sample is dissolved in approximately 35 milliliters of 6 molar sulfuric acid and heated on a hot plate to a temperature of 70 to 80 degrees. As you can see, the sample here was slightly overheated. Once the sample is up to the correct temperature, the heat can be turned off. The thermometer is removed and a magnetic star bar is added. The burette has been filled with 0.0200 molar potassium permanganate. Note the dark color of the solution, even at this low concentration. Be sure to record the starting volume of your burette. To properly read a burette, you read to the tenths and estimate to the hundredths. It is hard to tell from the camera angle, but the volume looks to be greater than 1.8 but less than 1.9. We'll call it 1.81. Finally, we are ready to begin the titration. The titrant should be dispensed at a rate of approximately 1 drop per second. This titration employs an oxidation-reduction reaction rather than an acid-base reaction. As the permanganate is added, it is reduced by the oxalate ion to the manganese plus 2 ion, which is nearly colorless. This involves a change in oxidation state from plus 7 to plus 2, which requires 5 electrons. Now we fast forward to the end of the titration. Notice that with each drop, it takes longer for the color to disappear. Once the oxalate ion is completely exhausted, there is nothing to reduce the permanganate ion, and 1 drop excess is sufficient to turn the entire solution light pink in color. Last, record the final volume of the burette. Again, to properly read a burette, you read to the tenths and estimate to the hundredths. The volume is greater than 29.3, but less than 29.4. We will call it 29.39.